So what I'm having here is the basic the code snippet to declare a node. Okay, so this is to create a structure which is called as node. Okay, and it has two data members. One is or data field, or whatever way you can pronounce, and this is first field which will contain the exact value, and the second field which will contain the next node. Okay, address of the next node. So this is something which creates link between one node and the other node, right? So first of all, understand one thing, that all the linked list, if you want to implement linked list, you have a an initial pointer, an external pointer called as start. Okay, so like we have top for stack, top variable for stack, and for queue we have front and rear. Likewise for linked list we have the start variable. Okay, the start is nothing but an external pointer which points to the first node, because you should have the address of first node, then only you will be able to traverse through the list. Otherwise if you lost the address, then you can't access the list. Okay, so you should have that first node. Okay, so this is basically, I hope it's recording. Yes. Okay, this is basically let's create a start variable, an external variable, an external pointer, actually pointer variable, right? So for that, either I can declare here itself, I can say start, and I put a semicolon here. But you can also, inside your main function, you can use this set of code. Okay, struct node start, because it's a pointer variable. Okay, so start pointer. Okay, in some books it will be called as head. Okay, so head is also correct. You can either call it head or start. Okay, so let me go with start throughout this course. Okay, so after that, you have to allocate memory to the start variable. Okay, you have to allot memory. Okay, because you are just creating, you are just writing the structure, you are not actually allotting memory for it, memory for the structure. You have to do that, right? How do you do that? Okay, so you can do that. So I'll say start equals to, you can allot memory using malloc function. Okay, I told you that, right? Malloc function. Okay, an malloc will take a single argument. Okay, the argument is the size which you want to allot. For example, if you want to allot 2 bytes, I have to put 2 inside here, malloc. Okay, but in this case I want to allocate memory for the struct node, and I don't know the exact size of this struct node data type, right? Because for in case of primitive data types, say I'll have integer will be having 4 bytes. I mean, to store an integer we need at least 4 bytes, right, in case of modern compilers. But here struct node is a user defined data type. I only define the struct node, and I don't know the exact size for this. So to get the size, you have to use the sizeof operator, right? So this is an operator which will give you the size. So inside sizeof, what should you pass? You should pass the struct node. Okay, and whatever be the size, and that number of bytes will be allocated. Okay, so it will be calculating the size of our struct node, and it will allot memory. Okay, and the memory will be returned as a void pointer. Okay, I'll explain what is void pointer. Okay, it will be returned as a void pointer, and of course you will be getting the first address. Okay, memory will be allotted, and you will be getting the particular address. A node will be created at your computer. If you do this operation, a node will be created. This is just writing. So node will be created if you use this operation in your computer, in your memory. Okay, and that node's address will be returned by this malloc, and you have to typecast it to struct node pointer, because you are pointing to a struct node. So you have to typecast it like this, because this is a void pointer. So you know what is typecasting, right? Converting to another data type. So this is a void data type. Void means it's nothing. A void, it states. So typecast it to a struct node. Okay, so start will be now having the address of the memory will be allotted. So start will be having the address of the first node. Okay, for only one node the memory will be allotted. Fine. So this set of code is very important, guys, as far as linked list is concerned. So please be familiar with this set of code. Okay, so okay guys, so let me tell you how to create linked list using C. So for that, let me go with some code. Okay, so as include stdio.h, and you have to include one more header file, guys, and this is called stdlib.h. What for? Because this has some functions called as malloc, calloc, and free, and you're going to use those functions. That's why you are involving this header file also. So please include this also, header file, in your program. Okay. So you're going to create a linked list. So first of all, let me define the structure of node. Okay, in outside main, always outside main, you define the structure of node. So first field would be the data field, and of course the next field would be struct node hash next, right? Okay, all right. So this is a self-referential pointer. This will refer to another struct node. You know this. We have seen this before, right? So this is the structure of a single node. Okay, having this in mind, let's go for it. Let's go for a main. Okay, so inside, first of all, always create a start pointer. Okay, start pointer. The first step you should do is creating a start pointer. Okay, so after that you allot memory for it. We have already seen this a lot times, right? You allot memory. Okay, so malloc. Okay, you use the sizeof operator, and we have seen this in the previous video, right? So struct node, and yeah, that's it. And you typecast it to struct node. Okay. We have seen this in the previous video, I hope. Alright, so this set of codes is compulsory. I mean, this set of codes are compulsory. This particular set of code, this will appear in almost all programs. Okay, so you should know how to create a structure, then how to create a start pointer. Start pointer is something important because it points to the first node of your linked list. Okay, after creating start pointer, you just allot memory by using this line of this line. Okay. All right, so yeah, so having this in mind, let's go on creating a lot of nodes. Okay, so how to create node? Let's say you have to use struct node hashtag, and it's a new node 1. Okay, new node 1, and I'll say new node 1, and you have to use the same syntax to allot memory, right? So new node 1. So this is how you can create node, guys. So if you want to create new node, then you have to use these two set of lines. Okay, you have to first declare it as a data type. It's similar to declaring as a variable int a. It's declaration, right? Declaration of a variable. Likewise, I'm declaring a node because I know this is the data type of my node. So I'm declaring a node. After that, I'm allotting memory to it. Okay, understand that if you declare a variable, an integer or a character or float or whatever it is, the system will automatically allocate memory for that. Okay, but if you are creating your own data type, then you have to allocate memory. Okay, using this set of this line. Okay, so yeah, I hope you understood this. So let's get the value. Let's create a single list. Okay, I'm creating only one element. Okay, start is not an element. Please understand that start is an external pointer. Okay, it is not an element of node. Of course, it has a data type, but understand that start is an external pointer. Your new node 1 is here actually. Fine. So let me have the data. Okay, new node, you know how to access the data field and next field of the new node. I told you it is an arrow operator. So use arrow operator, data, and maybe 50. Okay, so what I'm doing here is in the data field of new node 1, I'll be having the value 50. Okay, I'll be having the value 50, and again I'll create one more node. In the new node, the next field will be having nothing, null, which means that that is the end node. Okay, I have only one node in this list, so that is the end node. Okay, so that's it. After that, if I want, I can print the data value. Okay, so like this, you should always print like this. So I can print like this, right? Null, because you know that that's the end node. So end node should be printed like this, and you can print like this, new node 1 arrow data. So it will print 50, right? Let me run this code and show you. Oh my god, what happened? Okay, so here you should have a semicolon. Yeah, now it's working. It's a 50 points to, I mean 50, and the next node is actually, next field is actually null. Okay, there is no next field, so we'll get only 50. So what we are basically doing here is, of course here we have only one node, so start means start is unnecessary if you have only one node, but in some cases it might not having only one node. Okay, and you have to make start points to new node. How do you do that? you have to declare like this, you have to assign like this. Okay, new node 1 should be assigned to start, which means that now start will point to new node. Okay, so this set of code is compulsory for all linked list programs, and this is how you can create a simple linked list with only one node. Okay, so how to create a lot of nodes? Let's see that. Okay, let's see how to create more than one node and how to link them. Okay, so let me create one more node and let me have the data. Okay, so I'm just copy pasting it, and I just put 2 here and 2 here. Let me have 500 here. Okay, and what I'm going to do here is I'm just going to link these two nodes, guys. I'm just going to link these two nodes. Okay, this is my first node and this is my second node. How do I link? It's pretty simple, right? The next field of node 1 should contain the address of node 2. Okay, and understand that when I say new node 2, it is already the address. Okay, yeah, malloc function returns only the address, so new node 2 will have only the address. Fine. So new node of next will be new node 2, right? This is very important, very crucial to link the nodes. Okay, so what we are basically doing here is, let me go to paint to show you this. Okay, and let me go for new, don't save. Okay, so this is new node 1, guys, and assume it as this is new node 2. Okay, so okay, let me go for a straight line. So new node 1 we have data and next field, new node 2 also we have data and next field. Okay, so what we are basically doing here is this, observe this line, guys. New node of 1 next field equals to new node of new node 2. Okay, let me copy this and paste it here somewhere here so that you will get a better idea. Okay, so this line is very important, which means new node 1 arrow next. What does it mean? I meant to say this field, right? New node of 1 arrow next. This should point to new node of 2. I mean, this will point to new node of 2, which is obviously the second node. Okay, this is obviously the second node. That's it. That's the idea here. So that's how you can link the node, guys. Okay, and what it should point to, it should have the value null, because this is the end node. Okay, if you have one more node, then then this particular address field will point to that node. Okay, will point to that node, right? So that's how linked list work. Okay, and you can make that using this statement, this particular statement. You can do that, right? I hope you understood this. So I'll just give you a task here. Try creating a linked list with 3 nodes, and you can explicitly declare like this. Of course, in a practical case, if you want to create a linked list with n number of nodes, then you have to use some loops, and we'll do that in the next video. Before watching next video, please make sure that you create a linked list with at least 3 nodes and you link them. Okay, so that's the assignment that I should give you, and see you on the next video. Thank you.